Direct variation, okay, so are we gonna be multiplying or are we gonna be adding? I meant dividing. Okay, so our basic formula for direct variation is that y equals k times x. Now they're telling us specifically the area varies directly, so do we usually use y when we're talking about area? No, what letter do we usually prefer to use? A. So we'll have our area varies directly, so definitely the k there. As its length. What letter do you want to use for length?
L.
Sounds good. Okay. So here's our formula. Our A equals K times L. We've got that. It's multiplication because it's the direct variation. Now you start plugging stuff in. If the area is 50 meters squared, so if the area is 50 meters squared, Chrissy, are we going to plug in 50 for the A, the K, or the L? Just a hint, you're never going to plug it in for the K, ever. All right. So that's telling us that A equals 50. And then Cody, we've got this other information that the length is 10, so what are we going to plug in for the 10?
L.
L. So our equation now looks like we know A, it's 50 equals K times 10. If you want to get K by itself, divide both sides by 10. K equals 5. Everybody okay up to that point? Okay. Now you take that K value and you plug it back into your formula. So we have A equals 5L. On the 4 through 14, like that's when you would have been done because they just asked you for a formula. You solved for K, you plugged it back in, boom. This one goes a little bit further in that last sentence there where it says find the area when the length is 25. Okay, so we're taking it a step further. We're going to solve for the area when the length is 25. So at this point, are we going to plug in 25 for A or for L? There you go. So A equals 5 times 25. You have 5 quarters. 125 meters squared. Good. Yeah.
So
Now we're done.
That was pretty easy.
Variation tends to be, yes. Chrissy, questions on this example? So the 4 through 14, you would have been done at this point right here. Okay, the formula is what they're asking for, so you'd be done here. Now we're just going a few steps more. Mr. Cohagen, are you okay? Good. All right, so this looks bigger on your paper. Take a moment, read through it. Which type of variation are we dealing with here?
one that uses like everything.
Inverse, okay? So if it's inverse variation, what are we going to be doing? Dividing, yeah, okay. So our basic inverse variation looks like y equals k divided by x. But we're going to get a little bit more specific here. It says the cost of producing a single item. So what letter might we use to represent cost?
C.
C, sounds good. Equals, that k is always going to be there, so you're never going to change that. Now it's inversely the square of the number of items produced. Well, if we need to represent the number of items, what variable do you want to use for that?
I.
Sure, sounds good. But it does say the square of that, so what we're going to write is I squared. Cody, you okay up to there? All right. Sadie, you all right? Now this is the part where we get to plug stuff in. If 100 items are produced,
That go at the bottom.
very good. Okay. The 100 items means that I equals 100. Each cost $2. So where are we going to put the 2? For where the C is. So this now looks like 2 equals K divided by 100 squared. So we have 2 equals K divided by 10,000. And then how would you get K by itself? multiply by your 10,000. So that gives us that K equals 20,000. Now that we have that K, what do we do with it?
Plug it back in.
Where do you plug it back into?
Into the Z equals what the I.
Good. Take it, plug it back in up here. So now your formula looks like C equals, 20,000 divided by I squared. And there's our formula. Is that it for this particular problem?
So why wouldn't you use the K over X one?
No, because you have to find the closest per hour of 400.
Good. So that 400, are you going to plug that in for the I or for the C?
I.
Good. Cody, you're going to use it based right here. You always go back to the one that pertains to your problem. Now, if we plug in 400 for the I, that's saying C equals 20,000 divided by 400 squared. And you are allowed to use a calculator. Easton, would you like a calculator? Chrissy, would you like a calculator? I think you'll want, yes. You have one, Sadie? What'd you get? 0.125?
Okay,
No, I mean, might be fairly cheap. Whoa, that's different. 20,000 divided by 400 squared. Apparently we're making something like paper clips. All right, so the cost would be 0.125, or I guess, 13 cents. Do you have a calculator?
yeah, she used it to check. She didn't think it was right.
Do you have a calculator? There you go. All right. Mr. Furby, are you okay?
It's just the fact that you can do it is hard.
You're always tired. I didn't ask if you were tired. I asked if you were okay with this. I'm sorry I'm not pretty enough to keep you awake.
I was wanting to sleep in too.
Okay, on example 3, we've got an area of a triangle that varies jointly as the lengths of the base and the height. That means multiple things are going on here. Do you see the word inverse anywhere though?
No.
So we are not doing any division, which means it's all going to be multiplication. Now, the area varies jointly. So what letter are we going to use for area? A. Equals K times, it's talking about the lengths of the base and the height. All right, well, what do you want to use for base? And what do you want to use for height? Sounds good. Chrissy, in there anywhere, like, does it say the square of the base or the square root of the height? Does it say the square of the base? Like on the last problem, it said items, the square of the items. Do you see that here? No, so you don't have to worry about including an exponent or including a square root. If they want that in there, it'll say it in the problem. All right, so Easton, they gave us 10 feet. What's that? Sounds good. Will, they also gave us 4 feet. What's that?
Okay.
No, because you never plug in for K.
Have a look at the problem.
Hi, welcome. The height is 4 feet.
H equals 4.
Sounds good. And then Jessica, where does that 20 go?
A.
Yep. Okay, plug it in, solve for K. Lacey, what'd you get K to equal? Agreed. All right, now Cody, that we've got this K value, what do we do with it?
What do you do? Original?
There you go. So A equals 1/2 times the base times the height. Now, Jessica, we've got that formula. Are we done with the problem? No. Now what do we need to do?
Plug it up.
Do what? It's on the paper in front of you, since I know you can't read that.
It just says plug it up. Yeah, I get
Okay, so what are we plugging in?
it. Can't.
We already did that. It's right here.
Okay, you did that.
Yeah.
Well, that's 3 and 8. What's left of the problem?
There we go. What's left in the problem? The base is 3, the height is 8. So A equals 1/2 times 3 times 8.
Equals what?
What's the label on that since it's area?
Feet squared.
Good. 12 feet squared. Chrissy, you okay? Interesting. All right. So let's take a look at that example 4. The monthly payment P on a mortgage varies directly with the amount B borrowed. So what are we doing? We are multiplying, okay? And what's the first variable that's going to go down in our formula? P equals K times what?
Factor B.
B, because that's the variable they gave us, yes. All right, so if the monthly payment on a 30-year mortgage is $6.49 for every $1,000 borrowed, find a model that relates the monthly payment P to the amount B borrowed for a mortgage with the same terms. That's a lot of words. They're saying doing exactly what you've just done when you've got $6.49 for every $1,000 borrowed. Now, the $1,000 borrowed,
That's for B.
agreed, and the monthly payment is $649. So where does the $649 go? P, yes. Lots of words for, well, something pretty easy that they want you to do.
Yeah,
All right.
so 30 doesn't matter, it's just.
It does not, it's just extra fluff. Okay. If there was something in here about time based on years, then we would bring it in, but nope, doesn't matter for this problem. So that gives us 649 equals K times 1,000. So K is going to equal 0.00649, I believe.
Yeah.
Okay. All right, Chrissy, I have this K value. What do we do with it now?
Put it back in the problem.
Good. So we'll bring it back here, and it's going to look like P equals 0.00649 times B. This right here is the model that relates the monthly payment P to the amount B. So that gives us the model, or the equation, or the function.
So you should do that times 145.
Exactly. Now we have to take care of the other part of the problem where it says, okay, find the monthly payment when the amount borrowed is $145,000. So when B equals $145,000, plugging that in, taking that times the 0.00649,
So that's $941.05.
$941.
5 cents.
Thank you. There we go. That'd be the monthly payment.
Got it.
Mr. Cohagen, are you okay with this? Sadie, you okay? Mr. Kirby, do you have it down? Okay. Moving right along. All right, so on number 5, the number of vibrations per second, or the pitch, of a steel guitar string varies directly. All right, so what does that mean? Multiplying. Okay, so we're talking about the pitch. What letter do you want to use for pitch?
B.
P, sounds good. P equals K times the square root of the tension. Square root of t. Alright, then they also throw this word inversely in there.
So divide.
Divide the length of the string.
L.
Sounds good. Alright, so Chrissy, they tell us that the number of vibrations per second is 5. So what am I going to plug 5 in for? Yep. Mr. Cohagen, are you with us? If the tension is 225 kilograms, where am I going to plug in 225?
T.
Yep. Jessica, the length is 0.6.
0.65.
I think it's just 0.60. Yes. We still have to find K first before we can start plugging in the other stuff.
Yeah.
All right, so we got to solve for K now. So this gives us that 5 equals K times the square root of 225 divided by 0.6. So 5 equals, what is the square root of 225? 15K divided by 0.6. Lacey, how would we get rid of the 0.6? Agreed. So multiply both sides by 0.6. And if you take 5 times 0.6, 3? 0.3? Okay. 0.3 equals 15K. And then Easton, how do you get K by itself? Go for it.
Why is it?
Good question.
It's 3.
It is 3. Okay. I was thinking that,
It's
but
literally right next to my face, and it's 1.5.
we're going to make that a 3. We'll divide by 15. So I'm thinking that's going to look something like 1/5. Or 0.2. Either one's fine. So we've got that K equals 0.2. Now that we've found K,
We'll be back in.
agreed. Since I've already got a fraction going on up there, I'm going to write down K as a decimal, just so it doesn't look like a fraction within a fraction. So bringing it up here, that's going to be P equals 0.2 times the square root of T divided by L. All right, so we've got our formula.
Now I can look other stuff
Exactly. Plug the other stuff in. And what other stuff goes where?
in. 196 goes for T, 165 goes for L.
Good. The 196 is your T value. The 0.65 is your L value. So we're looking for the pitch. So we're going to take 0.2 times the square root of 196 and then divide that by 0.65. Those are all numbers, so you can just type them all in. You don't need to worry about moving anything around. Just type it in. I got it to be about 4.3.
Yeah, that's what I got.
Okay. Now, what's the label on this?
Vibrations per second.
M
Good.
or-
Vibrations per second.
Not too bad. Just can't get lost or you're in trouble.
That is true. Chrissy, are you okay? All right. Jessica, are you all right?
Yeah. Did you just call me Tracy?
No, it's like lazy.
Okay.
Okay, so then for tonight, what I'm going to have you do is on page 112, I'm going to have you do numbers
The E.
3 through 13 odd. Actually, you know what? I'm just going to leave it like that up there. I'll give you another go at those evens. Okay, so that's going to be tonight's assignment, and then also the study guide, the odds for tomorrow.